Hello everyone, this is Dr. Mihir Shah once again with another video. In this video, we are solving April 2023 university question paper under the subject Operation Research. This is the part 3 of a video series. Okay, this is one of the important video as important and little difficult topics have been covered under this, that is under question number 3, A, B and C. Okay, so let us see which all questions were available and how to solve them in the most simplest manner. Okay, now the first question, that is under question number 3A, it reads out as, from the following data, okay, draw a diagram, find the critical part and crash systematically the activities and determine the optimal project duration. They are giving you the activity, they are giving you the normal time, the cost time, the normal cost, the crash time and the crashed cost. Okay, and they are giving you something called as an indirect cost under that sum. Now whenever you get such kind of sum, okay, the very first thing what we have to do is we'll have to create a network diagram. Okay, so based on the activities that they are giving you, first let us create a network diagram. Okay, now the activities are given to us by 1 2, then 1 3, 2 4, 2 5, 3 4 and 4 5. So the very first, see, if you look carefully in the question, it's given 1, from 1 we have 2 and from 1 we have 3. Okay, so from 1 we have 2 and from 1 we also have 3. Then from 2 we have 4 and from 2 we have 5. Okay, from 2 we have 4 and from 2 we have 5, and then 3 and 4 together, from 3 and 4, we can again have another one which is 5. Okay, so now let us see how we draw this part. Okay, this is very important. Okay, now from 2 to 4 and 2 to 5 is given, so we make it okay, so I'll just make this here. From 2 to we have 5 and from 2 to 4 also we have, and lastly if you look, there's from 3 we even have 4, so we are connecting 3 with 4 and 4 is getting connected with 5. Okay, so our network diagram is done. So we have from 1 to 2, 1 to 3, 2 to 4, 2 to 5, 3 to 4 and 4 to 5. Now we'll just put the normal time under that. So for 1 and 2 the normal duration given is 8 hours. For 1 to 3 it is 4. For 2 to 4 it is 2 hours. For 2 to 5 it is 10. 3 to 4 it is 5 and 4 to 5 it is 3. Okay, once you get that, after that we have to note down the paths. So what are our various paths available here? The first path is 1 to 5 and the period to complete that is 8 plus 10, which is 18. Now they're talking about days, so it's 18 days. Second one, we can go 1 2 4 5. The times are 1 2 4 and 5, so 8 plus 2 plus 3, which is 13 days. Okay, next one we can have it as 1 3 4 and 5. The duration is 4 5 3, so 4 plus 5 9 plus 3 12. Okay, now let us check if there is any other duration available here. Okay, so these are the three. So we have 1 2 5, 1 2 4 5 and 1 3 4 5. From here a critical part. So the maximum value here, our maximum value is the 18 days. So our critical part will be 1 2 5, which is 18 days. Okay, once we make a critical part, the next thing under crashing, the next thing that we need to note down or we need to find is the total cost. Okay, then we can prepare the tables which are required for crashing. So for that we need total cost. So total cost is equal to direct cost plus indirect cost. Now direct cost is nothing but the total of normal cost. So now on your calculator, the total of normal cost is given as 100 plus 150 plus 50 plus 100 plus another 100 plus 80. So 580 is the value. So direct cost is 580 plus indirect given in the question is 70 per day. So 70 into a crashing limit is, a critical part was 18 days, so 70 into 18. So 580 plus 70 into 18, which comes to 1260. So when we add up with 580, we get the value as 1840. That's our total cost. Okay, now once we have done with the total cost, okay, now the next thing that we need to prepare is, the table. So for crashing the sum, okay, before crashing we'll require two tables. Okay, one where we have to create the maximal crashing limit and the cost slope. Okay, two things we need to find. So we'll create one table here, right? Okay, this is a working note table where we have activity. So first we note down that. The activities which are there in the question are, so we'll just note down those activity which is given as 1, 2, 1, 3, 2, 4, 2, 5, 3, 4 and 4, 5. The next column will be maximum crashing limit. The formula for which will be, now this is the maximum crashing limit, okay, so it will be normal time minus crash time. So in the question now, if you look carefully, normal time and crash time, both the times have been given to us. So now the normal time is 8 days and crashing is 6. So 8 minus 6 is 2. 4 minus 2 is 2. 2 minus 1 is 1. 10 minus 5 is 5. 5 minus 1 is 4. And the last one, 3 minus 1 is 2. Next, we need to find the cost slope. Okay, the formula for which is crash cost minus normal cost, the whole thing divided by the max limit that we just now found. Okay, so now if you look carefully in your question, okay, crash time, the cost was given as 200 and normal cost was 100. So 200 minus 100, which is 100. 100 divided by 2 comes to 50. Okay, same way for the second one, 350 minus 150, that comes to 200. 200 divided by 2 is 100. Next is 90 minus 50, which comes to 40, divided by 1 is 40. Then is 400 minus 100 divided by 5, which comes to 60. Then 200 minus 100 is 100. 100 divided by 4 is 25. And last, 100 minus 80 is 20. 20 divided by 2 is 10. Okay. Now with that, we just, last step, we need to rank them. So rank as per the lowest cost. This is the lowest cost, so I rank that as 1. Second lowest is 25. I rank it at 2. Then 40, 3. 54, 60 will be 5 and 100 is 6. Okay, so once that is done, Now we can start with our crashing. So we'll make now your crashing table. Now in order to make the crashing part, okay, few formats we'll have to create. The format of the table will be very crucial, okay. Okay, the first column will always be based on activity, so we'll note down this as activity. Okay, last three columns are going to be fixed, where we have, we'll have total cost, we have indirect cost, and we'll have the direct cost. Okay, so first I'll just note down, this is this I'll write it as crashing. Here I have direct cost, indirect cost, and total cost. Okay, this is like our total cost ka column, and this is the crashing ka column. And now here we'll have the paths, okay, the network path. So now if you look carefully, how many paths we had here? We had 3 paths. So we'll require 3 columns here, having those 3 paths mentioned in that. The first path is 1-2-5. The second is 1, 2, 4, and 5. And the third one is 1, 3, 4, and 5. From out of which the first one is a critical part. So we'll put a dot here to understand that is the critical part. After that, we'll have to write the very first thing, before crashing. The number of days which are given as 18 days. I put a dot because that is our crashing critical part. Then 13 days and 12 days. The direct cost was 580. Indirect is 1260 and total is 1840. Okay, I'll just put a line over here. So we know that this particular, from here we are going to start with the crashing part. Okay, now remember under crashing, the very first thing you have to remember is we'll have to go critical path wise, and we'll have to start crashing one day at a time. Okay, we'll have to keep doing that till the total cost reduces. The moment the total cost increases, the sum gets over there. Okay, so let us see how we go about with the sum. Now we start with the networking path. Our critical part is 1, 2, and 5. Check in the path 1, 2, and 2, 5. There are only 2 paths here. Check if any of those paths are available in our activity. 1, 2, and 2, 5. Now see, as rank wise, the very first activity you need to crash is 4, 5. But 4, 5 is not there in our critical part. So we'll have to look at the critical part. We have only activity 1, 2, and 2, 5. 1, 2, and 2, 5. Check. 1, 2 is rank number 4. 2, 5 is rank number 5. So I'll have to take the earlier rank, which is rank 4, which is activity 1 and 2. You can crash it twice. Okay. So chalo, we'll start with that. So I'm writing here crashing activity 1, 2 by 1 day. We are going to crash it by 1 day. You can crash it twice. Okay. So if I crash it by 1 day, activity 1 and 2, this will become 17. Now 1, 2 is also present here, activity 1 and 2. So this will also get crashed by 1 day. And here there is nothing, so we keep it as it is. Critical part is the most important thing here. Okay. So now we have crashed activity 1 and 2, the cost of which is going to be 50. So 50 gets added to your direct cost. So it will become 580 plus 50, which becomes 630. Now the moment 1 day reduce, so your indirect cost will reduce by 70 rupees. So 1260 minus 70, that becomes 1190. We added up to 630, we get the value as 1820. Cost is reducing, we need to go and solve further. Okay, same way, we only crashed it one more time, we can crash it one more time because maximum time you can crash it 2 times. So we'll crash it one more time. So we have crashing activity 1 and 2 by 1 more day. So this becomes 16 days. This is also 1 and 2 is also present here. So this becomes 11 days and this is as it is 12. Okay, 50 rupees will get added to our total direct cost. So 630 plus 50 is 680. Okay, and from 1190, 70 rupees will get reduced. So 70, say when you minus, you get 1120. When you add it to 680, we get the value as 1800. The value is still decreasing. We'll go further. Now this particular crashing is entirely over. Okay, we have completed with this entire crash. So the next crash which is available under network part is 2 and 5. Under 2 and 5, we can crash it 5 times. Is given there. So I'm writing here crash 2 and 5 by 1 day. So this will become 15 days. It is 2 and 5. Now 2 and 5 is not present here. So we note it as it is, and here also 2 and 5 is not present. We write it as it is. Now for activity 2 and 5, the cost is going to be 60 rupees. So 680 plus 60, that becomes 740. And from 1120, we less 70. So that becomes 1050 plus 740. Our total cost become 1790. Still reducing. We need to solve it further. One more time, we need to crash it down. So crashing again 25 by one more day. So this will become this will become 14 days. This is as it is 11. This is as it is 12. To 740 to the 740, we need to add 60. So that becomes 800. And from 1050, we'll minus 70, which becomes 980. When we add up to 800, it becomes 1780. So it is still reducing. We'll have to solve it much further again. So I'm writing here crashing again. Activity 2 and 5 by one more day. Remember, activity 2, 5, you can reduce it by 5 days. So this becomes 13 days. This is 11, this is 12. 60 days, 60 rupees gets added in that. So it becomes 860. From 980, we minus 70 rupees. So this becomes 910. When added to 860, it becomes 1770. Okay. Still the cost is reducing. So the moment it keeps reducing, we'll have to keep solving it further and further. So we have crashed 25 by 3 times. So we'll crash it one more time. Crashing 25 by one more day. So that becomes 12, 11, 12. 860 plus 60 rupees gets added to that. So that becomes 920. From 910, we less 70. So that becomes 840. When we add it to 920, it becomes 1760. Still reducing. We'll have to solve it, one more step ahead of that. But now comes the important part. Now if you look carefully in our critical part, 12. Now this is matching with this 12. So now they both are common. So now you'll have to find something which is common in both. If not, then we'll have to crash these two together now. So here only 25 is there. 25 we have crashed it 4 times. So I can crash it one more time. So I'll write here crashing 25 by 1 day. And under this 1, 3, 3, 4 and 4, 5. Check which is the lowest. 1, 3 is rank 6. 3, 4 is rank 2. And 4, 5 is rank 1. So I'll even crash 4, 5 by 1 day. So this will become 11 days. This is also 11 and this is also 11 days now. Okay. So 4, 5. Okay. Wait, 4, 5 was here also. So this will become 10 days. Okay now. So now. 920 was already there. Plus 2, 5. 2, 5 ka 60 rupees. Plus 4, 5. 4, 5 ka 10 rupees. So that becomes 990. Under 840, we less 70 rupees because indirect cost is reducing. Now when we add 770 with 990, we get the value as 1760. Okay, 1760, meaning now it is coming to a state where it's going to get constant now. Okay. So now the moment it becomes constant, you know that the next step will be much more. Okay, now if you look carefully, we are done with our crashing. Okay, 1, 2 and 2, 5, both these values have been over. So now I cannot go because main is our critical part. Now critical part cannot be solved further because we have crashed both. 1, 2 and 2, 5 both have been crashed. So this is it. This is the final answer. The next step, if there would have been any other step in that the price would be much more than that. Okay, so with that, the sum will get done. We just have to finalize. We need to note down the final value. So here, the optimal time is 11 days. That's the lowest day. and the cost, the optimal cost, is the value which came corresponding to that came to 1760. Okay, because we couldn't solve it further because both the crashings have been done. 1 and 2 has been done twice, and 2 and 5 we did all 5 times, so it cannot be further crushed. Okay, so optimal time is 11 days, optimal cost is 1760. So this is how you all had to solve question number 3A. Okay, I hope everyone have understood. This was some based on crashing. Okay, now the next question under question number 3 was question 3B. I'll read the question. You are given a solution for a transportation cost problem. Figures in each of the cell represents the unit of transportation cost. Figures are given with an allocated value with the in circle. You are required to check the above solution for optimality. If it is not optimal, use Modi method to obtain the optimal solution and find the optimal transportation cost. Okay, so now when such kind of sums are given, okay, the very first thing what we'll have to do is, we'll have to make a table. Okay, we'll have to create a table with the same allocation which they have given us. Okay, with 2 additional columns we'll require. So I'll just we'll first quickly note down this table. We have plant, we have been given warehouses, 3 warehouses, supply, and we need one more additional column after that. Okay, so I'll just note down, we have been given here the plant and the warehouse. So we have W1, W2, W3 and supply. And after that we need one more extra column called as the U, because we have to test for optimality here. And on this side we'll have P1, P2, P3, demand, and one more extra column called as the V, UV method. So the Modi is nothing but UV method that we need to find. Okay, they have given you some values, so we'll first note down those values. So it's given 18 the cost, 20, 16 the supply is 2000, 26, 22, 30, 2000, and last one is 6, 2, 0 and 2000. Demand is 1500, 3000, 1500, total comes to 6000. Okay, and they have given you, they have allocated some values and given us. So this is 1, the other one is this 22, 2 and this. Okay, so those are our allocated amounts of values that they have given you. So I'll just make a box over it. So basically we have to create the same table and we'll have to work out on that table. Okay, let us see how we go about with the sum. I'll just note down the allocated value, which comes to 500, 1500, 1000, 1000, 2000. Okay, so now in order to test for optimality, the first thing what you require is you need U column and V. Remember, U1 will always be 0. We need to find U2, U3. Same way we have to find V1, V2, V3. Okay, those are the things that we'll require to find. Okay, now first thing, remember to note down the formula. Okay, now in order to find for the allocate, now this is for allocation. Okay, for allocated values, we are finding for all allocated value. The formula is cost is equal to U plus V. So allocated, now this is the cost. Let's say if these are in the first row, the allocated is 1500. Cost is 16 is equal to U, which is 0, plus V. So if it is 16, so if you substitute in this cost ka formula mein, Okay, if u comes as 0, so 16 is equal to v. So v3 ka value will come to 16. Same way, 18 minus 0 is 18. So cost will, v1 will also be 18. Now with the help of v1, it is 26 is equal to 18. U plus 18. So plus 18 when goes and gets this side will get minus. So 26 minus 18 will give you 8. So your u2 will become 8. With the help of this, 22 minus 8 becomes 14. So this becomes 14. Okay, so we found v1, v2, v3, u1 and u2 for all. Okay, so all these things are done. Now for unallocated. For unallocated cells, the formula which you have to remember is the delta is equal to, we need to find delta is equal to cost minus u plus v. Okay, so let us see one by one which are the unallocated cells. The first is P1W2. So for P1W2, change is equal to cost. Cost is 20 minus u. For this particular cell, u is 0 and v is 14. So that is 20 minus 14, which is 6. Second, which is the next cell unallocated here, P2W3. So P2W3 के लिए delta is equal to cost is 30 minus u plus v. So that is 8 plus v is 16. So 8 plus 16 is 24. So 30 minus 24 is again 6. Next is 3, that is P3W1. Change is equal to 16 is the 6 is the cost minus u. Okay, we forgot to find u3 here. Okay, so we'll first find u3. Okay, it was 2 minus 14. So 2 minus 14 will give you negative 12 here. Okay, it was cost was 2. 2 minus 14 is minus 12. So u is negative 12 plus v is 14. Oh, sorry, we are finding P3W1. So u is negative 12 and v is 18. So that will become minus 12 plus 18 is positive 6. 6 minus 6 is 0. Okay, and fourth, we have P3W3. Delta is equal to cost, which is 0, minus 12 plus 16. So that becomes 4. So 0 minus 4 is negative 4. Okay, so now with this we were able to solve the UV method. Okay, first we found UV and then we found for all the unallocated cells. Now the rule is, under an allocation, if there is any negative, now here we got a value as negative 4, therefore solution is not optimal. Okay, if the solution is not optimal, we'll have to make it now optimal. We'll have to make it optimal through looping method. Okay, now the looping ka logic is very simple. From wherever you got this negative 4, okay, so negative 4 is under P3W3 cell. From here we will be starting off and we'll have to create a loop. Loop will be a closed loop. So let's say we go on top. Okay, so that is 1. Then we'll go see, here there is no side, so we'll have to go to the extreme side. Okay, then we come down because there's nothing else, we can't go further, so we'll go right, there's nothing further, we'll come down and then we will join it. So here we have a 6-point loop. Okay, so this is, so where you start with the point that is plus sign, minus, plus, minus, plus and minus. Now the rule is, wherever we have negative signs, so we have 1500 under negative, 1000 under negative and 2000 under negative. So from the 3 negative, the lowest value is 1000. So we'll write change is equal to 1000. Change is equal to 1000. So 1000 in the mean, it means that wherever plus sign, you add 1000, wherever it will be minus, we'll have to less 1000. So we'll have to create a new table for that now. Similar table, okay, but new allocations will be there now. So we will create first a table. Okay, similar, we'll have W1, W2, W3 and supply. The first is that plant and overheads. We have W1, W2, W3, supply U, P1, P2, P3, demand and V. Okay. The cost allocations remain same, so that we will keep it as it is. Okay, so costs are exactly same, so cost doesn't get affected, that remains as it is. Demand also and supply also remains as it is. Okay, now look at this very carefully. Okay. All our allocations had got affected. Okay, yeah. So now we'll have new allocations here. First was at 0. It is plus, so plus the change, so this becomes 1000. Second one was here, but it was 1500 minus 1000, so this will become now 500. Next, it was 500 plus 1000, which is 1500. Next, 1000 plus 1000 becomes 2000. And last allocation, 2000 minus 1000 is 1000. Okay, so this is our like a new allocated value that we have found. So we check allocated values are 1, 2, 3, 4, 5 allocations, and 3 plus 3 6, 6 minus 1 is 5. So they are now optimal. Okay, they are balanced now. Okay, so now we can we'll have to use our UV method to check its optimality. So U will be 0. Okay, so if this is 0, this is allocated, so 16 minus 0 is 16. V1, V2 and V3 will be 16. 18 minus 0 is 18. Okay, now what else can we find? Now with the help of this, so 0 minus 16 is negative 16. 2 minus 16 becomes positive 18. And with the help of this, 22 minus 18 is 4. So we were able to get U and V. Now we need to for unallocated. That's the most important. For unallocated cell, we know delta is equal to cost minus U plus V. So the first unallocated cell is P1W2. Cost is 20. So 20 minus U is 0. V is 18. So 20 minus 18 is 2. Second, P2W1. Cost is 26. So 26 minus 4 plus 18, which is 22. So 26 minus 22 is 4. Third, we have P3W1. Cost is 6 plus minus 16 plus 18. So that becomes 2. So 6 plus, sorry, this is minus sign. So minus 16 plus 18 is plus 2. So 6 minus 2 is 4. And the last allocation which is there is 30. So that is P2W3. Cost is 30 minus 4 plus 18. That is 22. So 30 minus 22 is 8. Now since all the deltas are positive, therefore it is an optimal solution. And if it is an optimal solution, therefore total cost, final answer, total cost is equal to 1500 into 18 plus 500 into 16 plus 2000 into 22 plus 1000 into 2 plus 1000 into 0. So that comes to 1500 into 18, which is 27,000. 500 into 16 is 8,000. 2000 into 22 is 44,000. And this was 1000 into 2, which is 2000 plus 0. So 27,000 plus 8,000 plus 44,000 plus 2,000. The optimal cost or the total minimum cost comes to 81,000 rupees. Okay, so this is how you all had to solve the sum based on question number 3B, which was based on Modi method. Okay, chalo, I hope everyone have understood that. Okay, now let us see the last question, how to solve that particular question. Now in the question it is given as, we'll read the question. Question reads out as, a project which is planned using Perth technology has given you the following detail. The average expected time has been calculated and they have given us, and the detail of standard deviations are given. We need to construct a network diagram of Perth, okay, and find the expected completion time of the project, calculate the variance and determine probability when the weeks are given, and determine weeks when the probability is given. Okay, now when such kind of sum is given, let us see how to solve it. Okay, the very first thing they ask us to find the variance. So what we'll do here is, we will construct a table. We'll construct a table where we have been given activity, we have been given the expected time, we have been given standard deviation, and now we need to find variance. So we'll first note down the activities given: 1 2, 1 3, 2 5, 2 4, 5 6, 4 6, 3 6 and 6 7. The expected time given is 3 4 5 6 7 8 9 and 3. The standard deviation is 4 by 6, 4 by 6, 4 by 6, 2 by 6, again 4 by 6, 4 by 6, 4 by 6, and last में 2 by 6, and they're asking us to find the variance. Okay, now variance is nothing but the square root of variance is supposed to be standard deviation, and standard deviation is, and when variance is nothing but the square of it. So 4 by 6 is nothing but 16 upon 36, 16 upon 36, 16 upon 36, 4 upon 36. We need to get the square. Okay, 16 upon 36, 16 upon 36, 16 upon 36 and 4 upon 36. Okay, so that is the first thing which is required, that is nothing but the variance. So we completed the second part where they told you to find and calculate the variance. Now we need to get the network diagram. So now let us see how to draw the network diagram. Okay, now in the question they are giving you activity 1 2 and 1 3. So from activity 1 we have activity 2 and activity 3. From 2 we have activity 5 and we have activity 4. So first activity 4 and activity 5. 2 to 4, 2 to 5, and now 5 to 6. So from 5 we have activity 6 coming out. 4 to 6, so 4 is also getting merged to 6. 3 to 6, so 3 is also getting merged to 6, and 6 is getting merged to 7. Okay, time 1 and 2 is 3 hours, 1 and 3 is 4 hours, 2 and 4 is 6, 2 and 5 is 5, 3 and 6 is 9, 5 and 6 is 7, 4 and 6 is 8, and 6 and 7 is 3. Okay, once we get that, so now we can note down the critical parts. So our first critical part here, we'll note down first the parts. Our parts are 1, 2, 4, 6 and 7. which is 3 plus 6 plus 8 plus 3, which comes to 3 plus 6 plus 8 plus 3, which comes to 20 days. This is all weeks, so it is weeks. Okay, 3 plus 6, 9, 12 and 20. The next path with which is available is 1, 2, 5, 6 and 7. So that is 1, 2, 5, 6 and 7. That is 3 plus 5 plus 7 plus 3. That is 3 plus 5 plus 7 plus 3, which comes to 18 weeks. Okay, next one is, that's only, so 1, 4, 5, 1, 4, 1, 3, 6 and 7. The timing of which is 4 plus 9 plus 3, which comes to 16 weeks. So our critical part in this whole thing, our critical part is the 20 weeks. So I'll note down here, this is our critical part. Okay. Now in this question, they had asked us to construct a network diagram per and find the expected completion time. So our expected completion time is 20 weeks. And calculate the variance, which is done. Now determine the probability and stuff. Okay, so now in order to determine the probability for completing the project in 21 weeks. Now in order to determine that, okay, in order to determine that, the first thing what we'll have to find is the standard deviation, okay, of the critical part. So that is very important. So what we'll write here is, before going and solving the probability, the very first thing what you need to find is to get the value of standard deviation. So standard deviation, now your standard deviations are directly given. Otherwise we would have to add variance, get the root of that and get. Now standard deviation is given, so I'll write here standard deviation for critical path. Now critical part is 1, 2. So 1, 2 is this, 2, 4, this, 4, 6, this, and 6, 7. So those are our critical paths. So we need to take it. So 4 upon 6 plus 2 upon 6 plus 4 upon 6 plus 2 upon 6. That's a critical. So we get those values. So it will be, denominator is common 6. We add up the top. 4 plus 2 is 6 plus 4, 10 and 12. So 12 upon 6 is nothing but 2. Our standard deviation is 2 for the entire sum. Okay. Now we'll do the third one. Now once we have standard deviation, we can easily get the values. Now it is given that determine the probability of completing the week. So they're asking you find probability for getting the work completed in 21 weeks. Okay, so they're asking you to find the probability when x is less than or equal to 21, where x is nothing but your duration. Okay, so now let us see how to solve that. Now we need to note down the formula. Z is equal to due date, which is x, minus the expected time upon standard deviation. Okay, which is nothing but, we need to first find the z value. The expected time they are giving us, x is 21. Completion time was 20 weeks divided by standard deviation of 2, which came to 21 minus 20 upon 2, which comes to 0.5. So our z value is 0.5. So we need to find the table value now. If z value is 0.5, stable value will be how much? Okay. So now we'll have to look into the chart. So I'll just open the chart, okay, and then we can find out what is the value of z. So just give me a moment. I'll just open a chart first, so it will become easy for you all to understand from where to get that particular. We need to get 0.5 ka value. Okay. So I'll just get this tab thingy right here so you'll get the idea. Okay, now 0.5. Now this table will be provided, normal distribution table will be provided. Now Z, value that we got in the question is 0.5. So check where 0.5 comes here. 0.5 is here. And the value which correspond to 0.5 is 0.1915. Okay, 0.1915. So now let us see how we use this particular in our sum. Okay, our table value we got it as 0.1915. Once I get the table value, we can now find the probability. Probability that the work should get over in 21 days is equal to 0.5. This is by default the formula 0.5 plus the table value which came to 0.1915. We add up, so we get 0.5 plus 0.1915 which comes to 0.6915 into 100 because we want it in percentage form. So into 100 we get the answer as 69.15%. So the probability of getting work done in 21 days is 69%. Okay, that was the answer for that particular part of the question. Now the last part in the same question, they have asked us, if the project manager wants to be 99% certain that the project should be completed on schedule, what will be the project duration? So the fourth is exactly opposite. They want you to find days when the probability is 99%. So we'll have to reverse me, we'll solve it. Okay, now we know probability is 99%, which is nothing but 0.99. From that we will minus 0.5. Exactly reverse me we are going now. So 0.99 minus 0.5, we get the value as 0.49. That is the probability value, or also known as the table value. So this is basically table value. So we need to search, okay, what is the table value resembling Z. So we need to find Z from 0.49, whatever we have got. So we'll again, I'll remove that chart and you see where is 0.49 in that chart. Okay, now 0.49, we need 0.49 or number which is close to 0.4. Okay, 0.9 is here, so 0.49. This is the closest value to 0.49. That is 0.4901. Okay, so the value which correspond to that is, now look at this very carefully. This is 0.49. The value which is corresponding, the nearest value that is corresponding to 0.49 is 2.3. And when we go on top to 2.33, so the value is 2.33. So our Z value is 2.33. Okay, now if Z is 2.33, we can put in the formula. Z is equal to days minus expected time upon standard deviation. So Z is 2.33, which is equal to X. We need to find expected was 20 upon standard deviation is 2. So we cross multiply 2 into 3 into 2. This is minus 20. So when it comes to the other side, it will come plus 20, will give you the value. So 2.33 into 2 plus 20 days. So we get the value as 24.66 weeks. That is the value of X. So the probability of completing the job in 99% is 24.66 weeks. Okay. So this is how you all had to solve the sum which was based on question number 3 based on Perth analysis. Okay. So I hope everyone have understood that. With that, we will be ending this video here. Thank you.